Moving on, we have thigh swing speed. And this one is pretty much exactly how it sounds. It is the maximum speed of the thigh as it swings forward on each stride. We can see in this first picture, we've got a runner who is in stance phase, and that lifted leg is at its highest recoil point. And what's about to happen is that leg is going to thrust forward as that stance leg takes off from the ground. And this is a really powerful action for generating energy to move forward. So why is this important? Well, as I just said, thigh swing speed helps create forward energy on each stride. And this swing thigh, like we just showed in that second picture, it's not just the leg that's on the ground that is helping us drive forward. It's a combination of the actions of this leg swinging forward at a high velocity simultaneously with that leg on the ground generating force that allows us to be able to achieve faster speeds and be able to transfer energy better. So this is a really key metric. A reduction in thigh swing speed can also indicate changes in the height of our foot recoil and also the timing of our swing, things we just talked about with the recoil angular range. If our recoil of our foot starts to decrease, or if it's a little bit lower because we have an asymmetry in that side or we're not using energy as well in one side, that can change the speed we're able to achieve with the thigh on that next phase of the run. And it can also change some of the energy costs of being able to swing that leg at such a speed. So this is a really key metric to measure from an energy standpoint as well. Asymmetries, of course, this is a really big one for me because asymmetries on thigh swing speed can point to weaknesses. And this can also include the opposing leg. Like we just talked about, this sort of synchronization between the leg that's on the ground and the leg swinging forward is a really key motion for being able to generate power and energy and propulsive force to be able to send ourselves forward. And when we see big asymmetries develop, sometimes it's the interaction of those two things that we can start to gain some information about how that foot on the ground is generating force. If it's not generating force well, sometimes we'll try to spike our thigh swing speed to try to sort of jerk ourselves forward or create a little bit more force to help balance things out and keep us moving. So what should we aim for? A higher speed to maximize forward energy, as we just talked about, and maintenance of this score for longer durations. The elite athlete data here, this is an interesting case. These units are in degrees per second. And so this is technically, this is going to be a measure of angular velocity as the thigh is rotating around the pelvis. So degrees per second is the unit for these numbers. In the 203 marathoner, we can see some pretty high values, 392, 400. Progressive speed, we see that thigh swing speed getting faster as they're creating more force to create that speed. And also, I would say overall for the 203 marathoner, pretty symmetrical numbers. In general, in my experience, this is one, this is a very detailed metric. We can really, really pick up imbalance as well. Most runners have at least some degree of asymmetry at a low level. The problem comes when we start to see some, that symmetry or asymmetries grow and get a little bit bigger, or if we see a large asymmetry on one side or the other. In this 218 marathoner, also a high performer, a little bit different information we can collect from this. We have pretty similar overall values on average, but we see a pretty large asymmetry between the left and the right sides at all speeds. And for this runner, it's something that they want to look at of, this is potentially lost energy production. This is essentially lost force production in one half of the stride on every single stride as they run a marathon, which, is going to be well over 100,000 strides. So this is an area where we need to be thinking about how these small differences add up through thousands and thousands of cycles to be able to impact our race performance.